Hey folks, welcome back to another video. Today we're looking at question 566, reshape the matrix. The way we'll be solving the problem is basically brute force. They haven't really given any sort of like time constraints or like space constraints where we cannot really create a new matrix. So we can just go ahead and create a new matrix if we need to solve this problem. And for time complexity, there's no restriction either. So we can basically go through each element one by one in the original matrix and replace them in the new matrix, kind of like this. Okay, so let's write out the approach. What would this look like? So approach is basically create new matrix and copy over elements one by one, and the time complexity would be O of n into m. Basically that would be the size of the matrix, and we're moving it over to another matrix of the same size, not the same size, but like at least the same number of elements. So it would be the same, and then the space complexity is also the same. Well, actually, in this case, it would be, if you want to be super accurate about it, it would be r into c, or even n into m, basically square. Okay, so it's relatively simple. Let's just get started. So double matrix, so 2D matrix, and let's call it new matrix would be equal to new int of size r c. Oh, we need to get the dimensions of the first matrix. So let's say int of m equals matrix of 0 dot length, and int n is equal to matrix matrix dot length, I think. Actually, yeah, let's just test it. System.out.print n m. I just want to make sure that this is how we actually extract the values. I think I might have made a mistake here. So let's just test that. And because it has to return something, let's just return the new matrix that we created, even though it's an empty matrix, just so that it doesn't complain. So if we run it, the results, okay, so we are getting 2 and 2, and in this case 2 and 2 again. Okay, sounds good. I think, what if we add another test case? Yeah, so basically I want to add another element to see whether it actually is fitting out the right values. So in this case, number of rows should be 2 and number of columns should be so number of columns, and this is number of columns, and this is the number of rows. So I basically mix them up. So let's do n and m, and in this case it will be correct. So if we run again, we have 2 number of rows equals 2 and number of columns equals 3. Okay, so now that we know that we're pulling out the values correctly, let's have 2 for loops for int I equals 0, I less than n, increment I, for int j equals 0, j, 0, j less than m, increment j, right, and then we need to basically keep a track of int car row equals 0, int current column equals 0 as well. Okay, so this case will be 4, and it'll just be a new matrix of current row, current column, would be equal to all matrix of I and j, and then you increment current column. Oh, okay, I think I made a mistake there. So current row, current column. Okay, and if current column reaches all the way up to C, that means we have reached the end of the current row, and that's when we need to do two things. We need to increment current row by 1 and reset current column to be equal to 0. Okay, so I think this is all we need. Let's try running this. We can, so basically these values were just added as test values, and they don't, like these numbers like 2 and 4, they don't fit the additional element. That's the reason why it's erroring out. So if we try running again, interesting. So there is an additional, okay, but why did it create this? Okay, let's see. New row, new column, current row, current column, and into in this case it did the right thing. In this case, number of rows equals 2, number of columns equals 4. Did I mess up, I wonder? So what are the test cases? I wonder if this is wrong. Okay, let's reread this. If we can reshape an M into N matrix into a new one with a different size R into C, you're given an M into N matrix, and the two integers R into C represent the number of rows and columns of the reshaped matrix. The reshaped matrix should be filled with all of the elements of the original matrix in the same row traversing order as they were. If the reshaping operation with the given parameters is possible and legal, output the new reshape matrix. Otherwise, output the original matrix. Okay, so in this case, actually, it's not possible. So this is 2 into 2, and we want this to be reshaped into 2 into 4, which is not possible. So basically, we are missing a base condition. If yeah, I think we need to check this here. So if R into C is not equal to n into m, we just return the original matrix. So let's try running this again. I think that's the base, like the edge condition that I'd missed. Okay, the first two conditions are okay. Let's try submitting it. Ooh. Okay. 1. Okay, this is just the third base case. Okay. Okay, so in this case, basically there's only one row. So that's the reason why it's not less than 0. No, but it's like out of bounds. And this is the problem. And why is this a problem? One, two, three, 4, and then okay. Let's print out what's happening in this case. Print ln, and then we print out all of the values to see which one is the problematic one. Okay, so what are the values that we care about? We care about I, j, current row, and current column. Okay, so if we run this, that's fine. 0, 0, 0, 0. And then the very next time, current row, current column. Oh, I wonder if we can actually, like, if we print this above right here before it's assigned, we'll get what the values are. So okay, let's try running this again. Okay, so 0, 0, 0, 0, that's fine. And the second time, but why does it even enter this for loop? It shouldn't enter the for loop because, and what is the value of n in this case? Because this shouldn't have been, this loop shouldn't even have entered if it is not, if n has been assigned to be, well, 1, and then n and m, and then let's just add like a thing here where it's like something that differentiates. Okay, so let's try doing that again. Okay, so number of rows. How did I swap it again? Number of rows and number of columns. So this is looking for the number of rows, n. This is looking for the number of columns, m. So should we swap this? So if I swap it, oh. Okay, so I guess the first time I was actually looking at it, I got it wrong. Right, okay, so that's how you solve the problem. I hope the debugging also helped. So you could go, it will also, I hope it showed you how to go about debugging something. Yeah, so the time and space complexity, we went over it already. It would be like n square, because we have to go through all of the elements in the matrix. If you have any questions about the problem, please let me know in the comments below. Again, don't forget to subscribe to the channel and like the video. I would really appreciate that. It keeps me motivated to make more videos. Thanks so much, and I'll see you folks soon. Peace.